Hi students, now I will talk about graphical interpretation of acceleration. You can find that in page 29 through 30. As we talk about the graphical interpretation of position and velocity, now we can find the acceleration from the graphs in, between velocity and time. We see the previous example, and we will, for straight lines, we will use now curves. It will be easy. We will draw also tangential lines to find the instantaneous acceleration. Okay. Uh, Let us now find the average acceleration between the points t equal to 0. This is equal to t equal to 0. And t equal 0.6. This is 0.5. 0.6, 7, 8, 9, 1. This is 0.6. So I need this point and this point. I need the average acceleration between the point A and B and C. I have to find where's the this point, what is the coordinates of this point. Okay, also between t equal 1, this is t equal 1, and t equal 2.2, this is 2.1, 2.2. This is time 2.2, and this is the point where 2.2 and the velocity, it is about minus 22 meters per second. I have the velocity here. Okay. I think it will be easy to you. I will compute the first one. I can compute it by just without drawing any lines. I'll draw the line, but I can compute the acceleration, average acceleration. I can put it A average is equal between, for the first point, between the point t equal 0 and t equal 0.6, which is equal to v final minus v initial over t final minus t initial. This will give me the acceleration. The average acceleration is equal to v final. If I have this 0 and this 10, so I have it, this one is 2, 3, 4, sorry, this is 6, this is 8. So the final velocity is 2 minus the initial velocity is 0. The time is here, the time is 0.6. I can put the time 0.6 and the velocity, which is 2.0. So the difference in time is 0.6 minus 0, which is equal to 2 over 0.6. And the acceleration is equal to 3.3 meters per squared second. I can put the units here also, but I don't need to confuse myself. I can keep them to the last, but I have to put them. I am a physicist. You are a physicist now. You are not a mathematician. If you are a mathematician, you need to put just the numbers. But in physics, we have units to know that and to know more about these quantities. Now the acceleration is a vector, so I need to use the vector sign over the acceleration. What is the direction of this vector? I told you before, the positive direction is with the x direction, the positive x axis. So in this case, I have positive direction, and this direction is the negative direction. Okay, so the acceleration in the positive x direction, or to the right, or to the east. Okay, I can also compute the acceleration between A and B. So the acceleration, average acceleration between A and B is equal to V at B minus V at A, which is the difference in velocities, the over the change in time. This is the T final, or TB, and this is TA. TB is 1.5, 1.6, 1.7. I will put it TB minus TA. I will put the numerical values. VB B, it is this is 0, 2, 4, 6, 8. It is 6 minus VA, which is the same value, 6, divided by time at B is, as we say, 1.7, minus the time at A is, this is 0 0.5, 0.6, 0.7, 0.8, 0.9, 0.9. This is equal to 0 over 0.8 meters per square second. We have no any accelerations, average acceleration between A and B, but that means if I draw a line, this line will be horizontal. The slope of the horizontal line is 0. The average acceleration for this line, or for this graph between these 2 points, is 0. But what if I take the instantaneous acceleration at point B? Okay, what I need to do is just to draw my tangential line like this, and I need to pick 2 points and compute the acceleration again, and I will do that now. You can do that by yourself. You are better than me, I think. This is my line. Your line will change a little bit. Okay, this is the error of our experiment. Each experiment has an error. This is experiment. I will pick this point, which is easy to be found. Where is the coordinate for this point? I will call it beta. By the way, we will deal with different samples in Greek letters. Okay, I will pick another point good to me, which is approximately this one, or maybe your line will be better than mine. I can take this point, or this one. I'll call it alpha. At alpha, I have t versus velocity at alpha, and at beta also I have t versus velocity at beta. What is the time at alpha? It is 2 seconds. What is the velocity at alpha? It is this is 2 in minus sign, 4, 6, 8. It is approximately 9 in minus sign, negative sign. So my velocity here, it is 9, and the units in seconds, meters per seconds. Okay, what about this point? The time here is 2.1, 2.2. The scale for x-axis or the time axis and the y-axis, which is velocity, it is different. You need to be aware about that, because look, from here to here is 10 units in velocity. From here to here is 1 unit in time. Okay, so the time at beta is 2.2, and the velocity at beta is negative 18. You can find that. Okay, now the instantaneous, or the slope for this line, which is the instantaneous acceleration at B, point B, is equal to the slope of this line, which is equal to the difference in velocities, or divided by the difference on the times. Okay, the velocity, this is V beta minus V alpha over T beta minus T alpha. Again and again, I can compute that, which is equal to V at beta is minus or negative 18 minus V at alpha is negative 9. T at beta is 2.2 minus 2.0, which is equal to negative. This negative with this negative will be positive. I have negative 18, positive 9. The result is negative 9 divided by 0.2, which is equal to how much? Negative 45 meters per squared second. Look, the negative sign means that the velocity at this point is decreasing, yes. Okay, what if I take the acceleration at this point? I don't know what the name of this point. The slope is negative also, but the slope is less in magnitude, less than the slope at B. That means the velocity or the body at this point increasing its velocity, but not in the same rate as in this point, in this period. We have change in velocity in 2 points, but this change is depend on the slope of the tangential line. Maybe if this one is negative 45, maybe this one is negative 30. If we have at the point A, this is the tangential line. At A, we have another tangential line at another point. Maybe this one. Look here. Sorry. Or this point here. The tangential line here is horizontal. Slope is 0. The acceleration is 0 meters per squared second. I think you can repeat this solution many times and calculate the instantaneous acceleration as you done before for the velocity, and you can find the slope of any line. See you in the next examples. Thank you.